Hi students, we'll study one more topic, that is transfer of heat. Transfer means the heat will flow from one point to another point. So how the heat will flow, like you know that how the current will flow in the in the circuit now, because we are providing the potential difference. If potential difference is there, current will flow. How the wind will flow? If there is a pressure difference is there, then wind will flow now, right? So similarly, how the heat will flow, there should be compulsory the temperature difference should be there. That means heat has to flow, heat will be flowing from therefore hot end to cold end onto this, right? Always heat will flow from hot end to cold end, high temperature region to low temperature region now. Therefore, so here how many modes the heat will transfer? So from one point to another point. So heat will transfer from one point to another point in three modes. What are they? One is conduction, and another one is convection, and another one is radiation. Now let us see the basic difference between conduction, convection and radiation. This is conduction. So conduction, mostly it will take place in solids, right? So next one is what? Convection. Convection takes place in fluids like liquids and gases. So next one is radiation. So radiation, so like does not require any medium for its propagation, no? So like we are, if you stay in the sunlight, no, so therefore after some time you'll be start you'll start burning onto this one, or feeling warm. Why? Because we are receiving the heat energy. From where is the heat energies came? No, from the sun. In between sun and earth, no, there is a lot of, there is a completely vacuum is there. It does not require any medium. Therefore, so it will travel in the form of like a electromagnetic wave. That is nothing but a infrared radiations, right? Infrared radiations, no. Therefore, in the higher radiations, no, it will be flow, no, and it will travel electromagnetic wave. We know the speed of the electromagnetic wave, no. So speed, it will be equal to speed of the light 3 into 10 to the power of 8 meters per second. No. Therefore, this is the fastest mode of transfer of heat, does not require any medium. Direct transfer from the source to the receiver. Here, if this will take place in only in the fluids, that is like liquids and gases, no. So here conduction will take place only in the solids now. Let us explain this convection in this topic, then separately we will discuss about conduction. No? First let us go for convection now. So you might have seen the boiling water. Like you see that we are boiling some water now. There is a water is there, no? Here there is a water, right? So the water is there now. Therefore, if you are boiling this water now, therefore we are supplying the heat energy. When you are supplying the heat energy to this one now, what will happen now? At the base of this, one now, so it will be get heated up. So the water at this point, when there is a base now, so the water will be get heated up. When it is getting heated up, what will happen now? Its volume will increase. So volume will increase, or it will expand, no, density will decrease. Low density object will not be at the bottom of the water. So low density object will be always move upward. So this low density object, no, or low density water, what will happen now? It will be trying to move upward because of due to the density difference. At the top, so it is not get heated up. This water, which will be slightly higher density compared to this one, no, so this water will go down because of due to the influence of gravity. No, you understanding? So this water will go down and it will get heated up, go up, again go down, again go up. Like this, the water will be moving, so from hot end to the cold end. In this process, in convection process, the molecules or the matter will move from hot end to cold end now. Therefore, so here molecular motion will take place now. Molecules will move from one point to another point. So from hot end to cold end. And this is only the convection which requires the gravity for its process onto this one. No? So compulsory gravity is required. Why? Because these molecules are going down. So compulsory gravity influence is compulsory is required for the convection. No? For conduction and radiation does not influence any gravity. No? but gravity is compulsory for the convection. That means boiling of this water like this, so convection current will be there. This flow of matter, we'll call it as like a convection current, right? So this type of convection is not possible in the gravity free space, no. Why? Because this liquid will not come down, so because here the gravity it will be able to help now. Here molecular motion will takes place, will move from hot end to cold end, right? So we'll see in our day-to-day life, no. So we'll see so many activity and so many situations, no, where gravity is and where convection is required onto this. In our houses, mostly the ventilators are kept now. Why the ventilators are kept now? Because so in our houses, no, we will be cooking and will be exhaling the air, no. That air coming out from our nose, no. Therefore, it will be hot. The hot air, what will happen? It will be tries to go up. Always it will try to go up. Therefore, at the top level, the hot air will be there. So that's why if the ventilators are there, through that ventilators, the hot air will go out. And the windows will be there, no. Therefore, when the air goes out, pressure will low through the windows. Therefore, cool air will enter. So enter from the windows now, like that. So cool air will enter from the windows, hot air will go out from the ventilators, right? So like that, the room will be contains like a fresh air always. Therefore, here also convection is required onto this one now. Clear? So mostly, so the trade winds, right? So trade winds, no, in our on our earth, no. Therefore, here earth, right? On the earth, no. So this is our earth. So here there is an equator is there. This is an equator, right? So equator, these are the polar regions, no. These are the polar regions. So what will happen now? Therefore, when the sunlight it will fall onto this one, no. So mostly it will fall near to the equator region, no. Therefore, here what will happen now? This region it will be get hot. So why? Because mostly the sunlight is falling on this point, no. So therefore, this region it will be hot. When it is hot now, what will happen now? The air onto this one now, it will be able to fly away, or it will be able to push down toward this side now. When the air goes onto this one, no, here low pressure is created, here the colder regions are there. So therefore, here high pressure will be there. From high pressure to low pressure, always winds will be flow toward the equator from here, no, from this equator onto this. So toward the equator, the wind will be flowing. Again after that one, what will happen now? Again when the pressure is more, here the pressure will be low. Again the winds will go up, go out. So due to this one, no. So these are nothing but a convection currents which will take place. Always the wind will flow on the earth surface from equator to the north, equator to the south. That's why our houses are mostly constructed so by north facing and south facing, because the air has to flow. See, you might have seen most of the times, no, will flow from north to south or south to north. Why? Because of due to this trade winds, right? So that's why our houses are mostly built by north facing, south facing, no. So why? Because mostly the fresh air will enter. So that's why we'll be building our houses by facing toward the north or south. Clear? So even if you go to beaches, right, in the daytime, if you go to beach daytime, what will happen now in the daytime? So here this is one land is there, this is one land, okay. So this is the land, right. So here, so this is a land is there. So therefore here there is a water will be there, this is a water, right, this is a beach. Clear? So in the daytime what will happen now? Therefore sunlight will be there. So when sunlight is there, no, so here the beach sand is there, no, this sand is having low specific heat. So what will happen now? When low specific heat, sand will be get heated up very quickly. So therefore when it is getting heated up, so therefore the air at this point, no, so it will go upward onto this one. So the air it will be able to go, or it will be fly off. So therefore what will happen now? Here due to the sunlight, no, the water is having highest specific heat, no. Specific heat of the water is very, very high. So this will not get heated up very, very quickly. So therefore this will become like a cold region onto this one, no. This will become like a hot region now. So cold region means mostly the air it will be present here only. Hot region means air will be able to escape, no. Therefore, at this point pressure it will be low and here the pressure will be high. So therefore, so the wind will be flowing from sea to the land in the daytime. That's why if you go to the beaches, no, continuously the wind will be flowing from the sea to the land is because of due to this reason, no, right. So this is the breeze is coming from the sea, we'll call it as like a sea breeze, right. So if you go in the night time, exactly the reverse. Why? So in the night time, what will happen now? In the night time, so therefore here because of due to the low specific heat of the sand, no, so low specific heat of the sand, so therefore sand will be get cooled very quickly, but water is there, no, the water will not get cooled very quickly, right. That's why in the deserts, no, you will see that in the daytime it will become like a very hot, but in the night time it will be remains tremendous cool onto this. Why? So because of due to the specific heat of the sand, so it will be very low, it will be get quickly heated up, so and quickly cools up. Therefore in the night time, therefore it will cools very quickly, so therefore all the air it will be present here, no, pressure will be high, but water will be having highest specific heat, no, so it will not cool quickly, therefore it will be remains like a hot region onto this. When it is hot region is there, the air it will be able to escape, pressure will be created low pressure will be there, high pressure, no, so therefore what will happen now, the wind will be flowing from so land to sea. Therefore, so this will call it as like a land breeze, that will be takes place in the night time. So sea breeze will take place in the daytime. These all are the right where we are applying the convection, no, right. Right, till now we studied about the convection and where we are applying on to this one, no. So now we'll go for conduction. What is this conduction now? So conduction I told you already, so therefore it will takes place mostly in the solids. How the conduction will takes place now, let us see. So what will happen, how the heat will move in the solids now, we'll see now. So there is a one rod we will take it, no, this is one rod, right. So this end, so it will be given, it is make us like a 100 degree centigrade heat energy, and this end it will be at 0 degree centigrade now. Here in this one now there is a molecules will be there, water, I mean these molecules will be there here now, right. So these molecules, no, so these molecules are rigidly fixed onto this, right. Now these molecules, what will happen now, here the molecules which are very near to this one, near to the hot end, hot reservoir, no, so this is cold end. So near to this hot, no, these molecules, what will happen now, these molecules will take the heat energy. This when it's taking this heat energy, so that heat energy will be stored in the form of a, these molecules will be able to vibrate here now, like that. So this molecule is vibrating, no, and this molecule, what will happen now, due to vibration, no, therefore this molecule will give the energy to other molecule. So again after giving energy to the other molecule, it will come back to the same position, then it will be able to move this other molecule, like that. So from one molecule to another molecule, the heat energy will be exchanged from one molecule to another molecule, but molecules will stay there only. But in convection, molecules are moving from one point to another point, but conduction, molecules will stay there only. What will happen now, molecules will exchange the energy from one molecule to another molecule. Therefore here energy of this molecule, it will be given to another one more molecule, like that. So therefore energy will be transferred from one molecule to another molecule, like that. When it is this molecule is gain the energy, it will be sufficiently energy, then so after sufficiently gaining the energy, it will be able to give to the transfer to the other molecule after this, like that. So the molecules will exchange sorry. So the molecules will exchange the energy, right, in between them, no, but molecule will stay there only, it will not move from this end to this end, right. So here molecules do not move from one end to other end, but what will happen now, they exchange their energy now, right. So in this way, while it is going from one end to another end. So therefore what will happen now, it will be get heated up, this region no slightly get heated up. Therefore if you connect one thermometers onto this one, no, suppose one thermometer if you are connecting onto this, so how the readings it will be there now, this thermometers no. So let us see. So let us see here. Right. So here how the if you connect the thermometers, no thermometers, suppose I am connecting one thermometer here, no, I am placing one more thermometer here, no, I am placing one more thermometer at this point, right. So therefore thermometer A, thermometer B, thermometer C. So when it is placing, no, therefore what will happen now, you will see that you will see that therefore the thermometer reading of this one, it will be slightly higher. So then further its increase will not be there, then slowly the molecules will exchange in energy. So that therefore it will be raising in the temperature up to certain level now. So then slowly the heat will be able to exchange from one molecule to another molecule, therefore it will be able to raise to certain height onto this. You understand? No? So like that, so this thermometer will reach more temperature. So why? Because it is very near to the hot end. So for this one, no, for this one, no. Therefore, so here the thermometers will be reading in this way onto this, right. So now what will happen now? Therefore, there one stage you are going to receive, no. So that stage, what will happen now at that stage, no. So how much amount of heat energy it is entering to this region, no, that much amount of heat energy it will be leaving out. So therefore, how much amount of heat energy for unit time entering, so which will be equal to amount of heat energy which is leaving, so which will be equal to this region onto this one. This state we will call it as like a steady state. So we will call it as like a what, a steady state. In the steady state, no, so therefore what will happen now, therefore amount of heat energy which is entering, that much amount of energy will be transferred. There is no further absorption, no, there is no further gaining in the temperature onto this. This state we will call it as like a steady state. Before that steady state, no, we will call it as like a variable state, no, right. So I think you understood what is conduction, convection and radiation. So to understand very clearly, very simply, so I will give one simple one demonstration or one activity, so that you can understand what is conduction, convection and radiation. Suppose we will do one activity, no. Suppose I want to distribute some chocolates, no, to the students. Chocolates means what, energy. So I am giving, I am heating that substance, right. So students means what, they are molecules. See, I will not go, therefore that heat source, no, will not go to each molecule and will not give, right. So I will not move, therefore, but I want to distribute the chocolates. So how I can do now? So first, radiation. Radiation is what? A direct transfer. Like we are receiving the heat energy from the sunlight directly, from the sun to directly. So there is no other interference medium, no. Molecules also will not do anything, direct one. No. That means I will take one chocolate and I will throw to one molecule. I will throw to one molecule. I will throw to one person. I will throw to one student onto this one. So directly heat energy is going to that person and receiving now. This is called as like a radiation now. Very fastest way. Clear? What is convection now? Convection means what? Molecular motion will take place. That means one by one person, no, I will come, I will ask them to come and will take the heat, take the chocolate, will go and eat it. So therefore they will gain the energy. Like that again they will come, you know, like that one by one, line by line, they will come, they will take the chocolate, go and eat it, like that. So therefore this molecular motion will take place now. So this is called convection onto this. Now conduction, what is conduction? Now listen clearly. So what I will do, I will make all the children to move, sit in a one straight line onto this. So what I will do, I will give one chocolate to the first person. What the first person will do, first person first of all eat it. So then second chocolate I will give, again he will eat it, again one more chocolate, again he will eat it, again four chocolate, again he will eat it. So I will give, goes on giving the chocolates now. Therefore ultimately he will reach to the one stage, okay. So sufficiently enough. Then if I give one more extra chocolate, no, he will never eat. So he will transfer to the other molecule. Like that, after fulfilling its molecular energy, so therefore he will transfer the energy to the other molecule. Other molecule, what will happen now? It will take, other student what he will do? He will take the again chocolate. So again I will give, again transfer, like that. So like that it goes on, and one stage it will reach, no. Therefore, if I give whatever may be the chocolates, if I giving, immediately transferring to the other person without taking the energy onto this. So that state only we'll call it as like a steady state. Therefore, how much amount of heat energy is entering, that much amount of heat energy has to leave onto this, right? So we want to calculate rate of flow of heat energy in this conduction now. So at a steady state. So you try to see this one, no? At rate of flow of heat energy. That means amount of heat energy flown per unit time depends on what factors now. It depends upon area of cross section. Area of cross section means what? If larger area is there, that means more number of molecules will be there. So heat energy transfer, no, it will be more onto this one. Therefore, more molecules are there. So more faster heat will be able to flow. And more amount of temperature difference, no. Therefore, if temperature difference is more, so then it will be heat transfer is also more, and by inversely proportional to the length of this one, no. Inversely proportional to the length. If larger length is there, no, therefore it will take lot of time to reach to the other end. So therefore, rate of flow of heat energy will be very lesser, inversely proportional now, right? So if I remove this proportionality, so what I can get it now? Now we can rewrite it as, so Q by T, you can write it as K is nothing but a coefficient of thermal conductivity, A, so K into A into delta theta by L. So this it will be the rate of flow of heat energy now. This rate of flow of heat energy is nothing but what? Is nothing but a power. So power is nothing but a rate of flow of heat energy in the conducting rod onto this. Clear? So where K is what? K is nothing but a coefficient of thermal conductivity. You are understanding? So coefficient of thermal conductivity now. Clear? So what is the unit for this one now? See here. So we can rewrite it as K. K is equals to, this is nothing but a power into length by area into delta T. So power is what? Power is nothing but a SI unit is what? SI unit is, so you can rewrite it as SI unit. Therefore, watt into meter by meter square into Kelvin. So what I can write it now? Watt by meter into Kelvin. This is only one of your NEET examination question. So they asked what is the SI unit of our coefficient of thermal conductivity. So next we can go for dimensional formula. So watt, power is nothing but a M1 L2 T minus 3 by therefore L1 into K1. Now M1, so L1 T minus 3 K minus 1, this it will be the dimensional formula, right? So you can understand if the K value is larger, so if K value is large, if K is large, what you can understand now? If K is large, rate of flow of heat energy will be more. That means quickly heat will be flowed from one end to another end now. But if K value is lesser, so if K value is less or K value is small, so therefore it is rate of flow of heat energy will be very less. That means if K value is larger, it is said to be good thermal conductor, and K value is smaller, so it is said to be like a not a good conductor, no. Like if K value is very small, no, therefore it is like a thermally insulator, right? So where we can see that in our bowls, cooking bowls, so cooking utensils, no, should have high K value. Why? Because heat should be transferred very quickly throughout that bowl, no. Therefore, so K value should be very larger for our cooking utensils, and for utensils, no, to hold it, there is some rubber socket is required, no. So for that one, no, K value should be smaller, so that heat will not be able to transfer to that. So like a wood, rubber, no, therefore they say to be thermally insulator, no. So like copper, mostly the metals, no, they are thermally conductors onto this, right? So in the next part of this video, therefore we will study very detailedly, so more applications on this one, no. So about this conductivity, like rods are connected in series, parallel, junction temperature, all this one, no, we will discuss very clearly in the next part of this. So thank you, subscribe to my channel. So thank you, students.